Okay, so I'm going to start with the big boats, and then after that I'm going to talk about little boats. Marine radio in the 80s. As you probably know, nowadays there's a thing called GMDSS, which is an automated system based on VHF selective calling, satellite communication, modern technologies that is operated by the deck officers. So ships no longer need to carry a radio officer. That wasn't always the case. Somebody wrote this. I'll let you read it for yourself, but basically they're saying, in the current state of the art, you've got to carry somebody who knows Morse code. But within a period of time measurable of months, that's going to change. We're going to have radio telephony, and we'll be able to train the deck officers to use the radios. So what they were sort of predicting was basically GMDSS. Does anybody want to have a guess when that bit of text was written? The clue's in the kind of language. It's obviously quite archaic.
Pre-war?
1907. That's quite a bit of prediction there, because at the time, you've got to bear in mind, at the time the technology was... Well, AM had only just been invented. AM was first demonstrated in 1900 by Fessenden, right? The diode valve was invented in 1904 by Fleming. A guy called De Forest stuck a couple of extra electrodes in it in 1906 and invented the Audion, which was basically a triode. And they didn't even think about making one oscillate at RF frequencies until 1912. Yeah, well, it's spark gaps and also high frequency alternators. You could make a mechanical machine that would generate a very high voltage at, well, probably long wave frequencies. You certainly couldn't get much above a few tens of kilohertz. But that's right, there is still one operating in Sweden called SAQ, and I think they power it up on Christmas Day or something, don't they? And send a few Vs or something with it.
Yeah, that's only because Santa's going over the top.
Yeah. So anyway,
I don't know if it was of that era, but there's also a thing, was a hybrid between the two called a singing arc.
Right.
Where you had a rotating spark gap.
Yeah.
You do it a bit like a distributor on a car.
Yeah, so it's a spark excited by an audio frequency. Yeah, indeed. So the technology, when this was written, was very much spark transmitters. They possibly had valve detectors in receivers by then, but they certainly didn't have oscillators. And in fact, the guy I mentioned, Fessenden, also invented the concept of the beat frequency oscillator to detect a CW transmission, but that didn't come until much later. So we were talking here about spark with a dirty audio frequency, which was what you received in the headphones, and this guy's predicting GMDSS and saying it's around the corner, it's going to be a matter of months. Well, brilliant bit of prediction, but he was about 80 years out really with his prediction. Because everything he predicted didn't really happen until GMDSS was introduced in 1988, and that's the time at which selective calling technology was available on VHF, at which satellite technology was becoming feasible. And that's when they said, okay, we don't really need people learning Morse code and this statutory requirement to have a radio officer on board. Now we've got all this technology, we can make it user-friendly enough that the average deck officer can work it. So that's when the third mate started working the radios instead of having a radio officer.
I thought they were supposed to be able to repair them as well, actually.
Hang on a minute.
And maintain them.
Why is the man from Uncle sitting in the
I was going to say, does anybody know what's going on here? It is.
Yeah.
What's his name though?
Well,
no, his real name.
Oh, I can find out if you want to know.
I thought somebody would point out that it's actually Ducky out of, what's that police programme where he's a pathologist? Anyway, NCIS or something. It's David McCallum.
Thank you.
All right, what's the name of the film? What's the film?
Oh, well, I am faintest.
Titanic?
MGY, Call Sign of the Titanic, yeah. It's A Night to Remember.
Oh,
Right.
I didn't realise he was in that.
He was, yeah.
He must have been really young.
Yeah.
The reason it's M, because Marconi used to issue the call
Yeah, he did,
signs,
didn't he? Yeah.
which is
Alright.
why we now, with M, half the people in this room have got M call signs.
Yeah.
Yeah.
These came later.
Because
Right.
Marconi issued M to every Marconi station ship.
So, radio communication first deployed on ships at the turn of the 20th century, at which time the technology was obviously telegraphy only. Spark transmitters, maybe some of the shore-based stations had alternators, and there were no statutory requirements. You might or might not have a radio officer. There was nothing standardised in terms of frequencies, watch-keeping hours or anything. And then the Titanic thing happened, and the IMO gets together and says, we need to sort this out because, you know, having ships passing by the Titanic that haven't got radio and could have saved people but didn't, that's not acceptable. So that resulted in a whole bunch of changes. The equipment requirements were standardised. All right, so a size of X tonnage had to have a certain type of radio, transmitter and receiver. Watch keeping hours were standardised. All right, distress frequencies were standardised because there weren't any, you know, but spark transmitters were tuned by how long your aerial was. Remember, it was the resonant frequency of any coupling and the resonant frequency of the antenna that determined the wavelength of what you were transmitting on. And regular silence periods were introduced. I know David's got one of those clocks with the
Yes, I
silence. Yeah.
If I'd known, I would have brought it along. And
Oh right, I've got a picture of one later. So I don't
yeah,
Whole bunch of-
to me as for a
Right.
Christmas present last year.
All right. Whole bunch of technological changes followed. So we had, most importantly, of course, telephony. Right, amplitude modulation. Then single sideband came along, and finally FM on VHF, which is still used today. Automated telegraphy, RTTY, and later on Cytor, which is a commercial version of Amtor. Who remembers Amtor? I know there's some people in this room old enough to remember Amtor. HF for long distance communications. Oh, that's because in the early days it was all long wave. Frequencies above 2 megahertz were like, oh, they're no use to anybody. Let the radio amateurs play with that. It's no use for anything else. And VHF FM, which enabled direct bridge-to-bridge communications between deck officers, because you know they're probably intelligent enough to pick up a microphone and press the PTT. But Morse code remained important until GMDSS was fully introduced. That really carried on until the sort of late 80s, early 90s. And that's eventually when the radio officer role was dropped. So we had about 75, 80 years of good times. All right, so I came into this in the early 80s. I left school in 81 and I got a job with BP Shipping. All right. All my friends were going off to university and worrying about getting a student grant and how on earth would they live on it. And they said to me, what are you doing? I said, I've got a job. Ready? Okay, doing what? I'm going to college for 2 years. That's not a job. It is if they pay you. So I was at Leith Nautical College in Edinburgh. And the career path involved 2 years at Nautical College studying for a thing called the MRGC, the Marine Radio Communications General Certificate. And I'll pass this around. This is one I made earlier. There you go. Ooh, it's the real thing. Then you spent 6 months at sea as a junior radio officer. All right? And that's when this thing got validated to say you'd spent some time at sea. Then you go back to college and you do the radar maintenance certificate. All right? And then you're eligible to go on a ship on your own without a senior radio officer. So that was the career path back then. I got as far as that bit. I actually did 5 months at sea, so I'd have to have done another month after the radar. And then I met this girl and things changed. So that's when I got a proper job ashore. No, it's not Karen, by the way. So yeah, that's the certificate you got, which I'm passing around, and it says all the things you had to do to get the MRGC, the Maritime Radio Communication General Certificate. So it required, obviously, knowledge of principles of electricity, theory of radio and electronics, kind of a bit like the old RAE. But then you had to understand the workings of radio receivers and do a practical demonstration of fault finding. So the test involved, there's a receiver and you might find that one band's dead because somebody's messed about with the band change switch, or maybe it's as deaf as a post because somebody's actually pulled out the front end transistor, something like that. But that'd be the sort of thing they do. Morse code at 20 words a minute, and knowledge of applicable regulations, and what's called the SOLAS Convention, the Safety of Life at Sea. So there's all the regulations that pertained to the radio operator, like all the Q codes you had to know was part of the SOLAS Convention. A lot more Q codes than you have to worry about. There were other things we had to do as well, like, for example, basic sea survival. Certificate of efficiency as a lifeboatman. Yeah. What's this one? Oh, that was actually on board the ship, that one. Oh, and first aid. All right. And then when you actually got to do your sea time, you had to spend some time at the helm. So there's a helmsman certificate.
Well, you had to do everything.
Oh yeah, yeah. It's I've lost my firefighting certificate. I had to do that as well. So this was during that 2 years.
At sea, wasn't it? You had to do firefighting at sea.
It was actually at Leith Fire Station.
No, but I mean it was based on.
Oh yeah, yeah.
firefighting.
What it involved was they had a mock-up of a ship at Leith.
This is why.
Come
we
in.
moved to the
They had a mock-up of a ship, and they stoked up an oil fire in this thing, and it was completely dark. So it was full of smoke, hot enough to singe your skin, and you had to go in and find a dummy and drag him out, wearing breathing apparatus. Now there were firemen in there to pull people out in case you got into trouble. and that sort of thing did happen. So that was the kind of stuff we had to do. In terms of the equipment, this is all pretty standard on any appreciable size ship. There would be a main MF-HF transmitter, which would be 400 watts on MF. What I mean by MF is the around 500 kilohertz, which was used for coastal distances, Morse. And also upper sideband around 2 megs, the old fish phone stuff. Anybody that's worked top band in the 80s and 90s will remember that. I think it's all gone now. That was Loran, wasn't it? Or getting all the sound effects out. Decca, that was it. Yes. Okay. Well, that's all gone now, of course. So there'd be a main transmitter, MF, 2 megs, and HF, and the HF bands were 4 to 25 megs. All upper sideband or CW, except 2182 and 500 kilohertz, which for some archaic reason had to be AM on 2182 and modulated CW on 500 kilohertz. And I've never understood why, because nobody was using receivers that archaic that it really mattered. But anyway, there was a standby transmitter, and that had to operate from a 24 volt or 48 volt DC battery, so it operate from the main ship's batteries. Main HF receiver and a standby receiver, which again operated from batteries. Very often they were the same model of receiver, just one had an AC power supply and one didn't. But they all covered sort of 200 kilohertz up to 30 megs, so you do the long wave broadcast band right through the Morse bands around 500 kilohertz, the MF band around 2 megs, right up to 25 megs and beyond. There were usually several VHF FM radios, one on the bridge. Maybe the captain had, if not a radio of his own, then certainly an extension speaker and microphone off the main VHF radio, and there was one in the radio room as well. And there were very often handy talkies. Handy talkies back in the 80s, if you remember the FT202, something like that, it was a big brick thing with half a dozen crystal controlled channels and NICADs that lasted about half an hour if you were lucky. Radio teletype. I mentioned CITOR, didn't I? I used a protocol similar to the amateur AMTOR system. Forward error corrected teletype, in other words. I'll come on to that in a bit more detail later. Weatherfax receiver. All right, that received signals from Bracknell, right? Yeah.
The actual transmitter was somewhere up the M1.
Up a bit of somewhere.
But, you know,
Yeah,
the
well,
receivers were.
Yeah, the weather was invented in Bracknell. When I say fax, do you remember the ZX Spectrum printers? Yeah, with the silver paper, right? It was like a big one of those, because they didn't have this sort of xerographic printing technology that modern fax machines used, or thermal even. It was sparking and burning into this silvery stuff, so you'd end up with black on silver weather maps. Pretty weird stuff, and it smelt awful.
It's hard to read as well, isn't it?
Yeah, that's right. LoRaN, just talked about that. I think Decca had gone by the early 80s, but LoRaN was still around. LoRaN worked around 100 kilohertz. Lifeboat radios, that was the other thing. You had at least one lifeboat radio, which I'll come on to in more detail, but that would work on 500 kilohertz and 2182 and possibly also 8364, which was another emergency frequency. The standby transmitter always included an automated keying device in case the radio officer had drowned or something terrible had happened to him by then, so a deck officer could come and push a button and set it in motion. Basically a clockwork device that was programmed to send a string of long dashes and then SOS. Right? Frequencies in use, coastal telegraphy. This is now completely obsolete, you won't find it. In fact, 500 kilohertz, I think, is an amateur frequency now, isn't it?
No.
No?
472.
472, right, okay. I knew it was around there somewhere.
502 or something we had for a few years.
Right, okay. Okay. So these were used for Morse. 410, 425, 454, 468, 480 and 512 were the working frequencies. 500 kilohertz was calling and distress. 500 kilohertz you had to use modulated CW for some archaic reason, even in the 80s. The others were just CW. Yeah, as it says there, distress frequency was 500 kilohertz. Coastal telephony, this was around 1700 to 2300 kilohertz, upper sideband, apart from the calling frequency 2182, which was good old AM. Very often it was actually A3H rather than AM, so it was upper sideband with a carrier re-injected, because it's kind of complicated to make a transmitter that does proper AM and proper sideband.
Lumber radio, nitrogen radio.
Yeah, that's it. Come on to that. All ships, yeah. And then of course the long distance stuff, which came from Portishead, which was 468 up to 25 megs. And 8364 kilohertz was used for distress. It still is, I believe, used for distress. Then of course the VHF stuff, this is still around, we were just talking about that. 156 to 162 megahertz, 50 kilohertz channel steps. Calling frequency was 156.8. If you count up from 156 in steps of 50 kilohertz, channel 16. All right. Most of those channels were simplex. There was also a bunch of full duplex channels with a 4.6 megahertz offset, so that suitably equipped ships could actually do a full duplex telephone call with a suitably equipped base station. Okay, where were we? Oh yeah, now part of GMDSS is a thing called AIS, which is a pair of channels, 25 kilohertz high and 25 kilohertz low of 162 megs. And that's low speed data, and that basically replaces what the radio officer used to send as a transit report. It's basically just an automated transponder that pings out who you are, where you've been, where you're going, which in the good old days was sent as Morse as a transit report. Coast stations, there you go. Right, so the ones in red were the ones equipped with MF, your 500 kilohertz and your 2 megahertz. The one in blue, Portishead, was the HF station that covered the rest of the world. If we looked at a map of Europe, there was more of them all around France and Belgium and Germany and so on, but these were the ones in the UK.
I did my Morse test at ANC Radio.
Yeah, right, okay. Mm-hmm. So obviously 500 kilohertz during the daytime doesn't go a huge distance, which is why you've got them spread around the coast like this, They probably have a range of about 100 miles across sea during the daytime. They go a lot further at night, of course, but the idea was you really needed about 100 miles of range, which was doable. And the same on 2 megs when they were doing the telephone calls and the fish phone type of activity. So, statutory watchkeeping. I mentioned this back at the beginning. After the Titanic, the IMO gets, the International Maritime Organisation gets together and says we need to sort of standardise on watchkeeping. And what they came up with was everybody has to be keeping watch on 500 kilohertz and 2182 if they're suitably equipped, at least from 0800 to 1200, and a further 4 hours of the officer's choice. You might look at that and say, okay, so he had to work out 8 hours. That's a cushy job. This is 7 days a week, and he had to do lots of other things when he's not. All right, there's a whole bunch of other activities he had to take care of, so it wasn't a cushy job at all. Outside these hours, an automated receiver on 500 kilohertz would listen for the preamble of SOS, which was 12 long dashes, 4 seconds on, 4 seconds off. On your clock, as well as the silence period, have you got the minutes marked off in red bands?
I really don't know.
Right, I didn't see that there, but it's like red, 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 and then white, and red, 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 and white.
Is that for the second hand and you watch
Yeah,
it,
that's-
so you send when it...
That's it. Like you're trying to, how on earth anybody did that, I don't know.
Green and the red.
But that was the idea. And back in the 80s, of course, the way the auto alarm receiver worked was some sort of charge pump, because you didn't really have proper digital electronics back then. It was timers and charge pumps, and it would need to receive at least 5 valid DARs before the bell would go off in the radio officer's cabin. There were silence periods, so people could listen to emergency calls. So on 500 kilohertz, it was 15 to 18 and 45 to 48 minutes past the hour, which is why you've got this sort of red segment on the clock. And on 2182, it was 00 to 03 and half past to 30. There you go.
Yeah.
Have you got the red bands around the outside
Yes.
as well? There you go, that's what they're for.
Pass it round or something so that people
Yeah.
can see it.
Look at it afterwards.
Right, look at it afterwards then.
Okay. So yeah, the ship's radio room clocks had the silence period displayed, green for 2182, sometimes blue. I've seen blue ones as well, red for 500. You can actually buy these things on eBay.
What, clocks?
Yeah.
Yeah, you can, but
Yeah.
they don't really, they cost an absolute fortune if you want a real.
Oh yeah, proper brass one. Yeah.
It cost £75 for mine and it's a reproduction. So.
Yeah. Okay. And as I said there, you've got the red markers for the long dashes. Transit reports. This was what was replaced by AIS. So you would send a transit report regularly and include the following details: date and time, ship's name and call sign, where you've gone from, where you're going, and your estimated time of arrival. And that was all sent in Morse to the nearest 500 kilohertz coast station, or on a working frequency, so 480 or one of those working frequencies. So that's called a transit report.
So when they automated that, did you have a way of recording things like the ship's name and call sign in it permanently, and then?
Well, that's what AIS does. Yeah, the AIS transponder is sending this on a regular basis.
So you key it in or something and it will.
Yeah, the deck officer will program the AIS transponder with, I've just left here at this time and I'm expecting to get there at that time.
Yeah.
And if people don't turn up, then
Very right.
the cloud will somehow alert people to the fact that this ship should have arrived and it hasn't. Where's it gone? And that's when you start tracking back. Well, when did we last hear their AIS transponder? Satellite phones were just starting to appear in the early 80s, but it was horrendously expensive. It used a thing called Marex. There were 3 or 4 satellites. It's what eventually became Inmarsat, but they were the Marex satellites. $6 a minute to make a phone call. Right, that's a lot of money. That's a lot of money now, of course, but it's a lot of money back in the 80s. So what the crew used to do was send things called ship's letters telegrams, SLTs. And again, that was sent in Morse to the nearest coast station, possibly to Portishead if you were sort of transoceanic. I don't know if that's very clear, but that is what you received as a telegram. Remember telegrams? Yeah? Right. It used to be delivered as a telegram. It says here, Mum, received letters, many thanks. Tell MMO office Southampton to keep my certificate at their office. We'll write again soon. All my love, Eric. So that was written down on a ship, given to the radio officer. He would then send that to his nearest coast station. It's got an address there, Winding Way, Salisbury, Wiltshire. So then the telegram boy on his bike would go and deliver the telegram.
That's similar to the phone patch type stuff in the States, isn't it?
Yeah, yeah. So phone patch again. That was yeah. There was phone patch as well. So I was about to come on to that. So a number of the VHF channels had a 4.6 meg duplex split. So you could do full duplex phone calls if you were within 20 or 30 miles of the coast, of course, because it was VHF. And there are also duplex pairs of HF channels. So a suitably equipped ship could do a duplex phone call. More likely it would be simplex though, because duplex on HF it didn't really work very well. The pair, if you look on a book in the books, these pairs of frequencies still exist, but there are no coast stations actually supporting that now because satellites. Yeah, who needs it? One of the other responsibilities was a thing called OBS, observations, weather. So the deck officer every day would take sort of temperature readings, wind readings, is it sunny, how many octaves of cloud, all that stuff, and transpose it into a bunch of 5-digit number groups, not to be confused with number stations, which is something entirely different. I mean, all know about those if you don't Google it. So you'd end up with being given a telegram to send, which was just lots of 5-digit groups. And that would basically encode the ship's position and everything that you might want to know about the weather, where the ship was. So the OBS telegrams were usually done by the third mate, who would give this bit of paper to the radio officer, who'd send it to the nearest coast station, wherever it happened to be. And somehow it found its way not only to Bracknell, which was where the UK Met Office was at the time, but to all the other Met Offices in the world. It was all shared, public domain stuff. And they would stuff it into supercomputers or whatever they had at the time, and it would come up with weather forecasts based on what all these ships all around the world were doing. Cytor. It wasn't all Morse, some of it was sent by teletype. And the system used was Cytor, which is very similar to Amtor. It was forward error corrected TTY. So instead of using Bodo, which is a 5-bit code, it was encoded as 7 bits with some redundant bits. So that was still being used into the late 80s as well. But again, satellites came along and made all this sort of stuff redundant. But that was very, very similar to the amateur standard, Amtor. Lifeboat radios. So if you had lifeboats, you had to have a lifeboat radio. And it was probably only a couple of watts on 500 kilohertz, 2182 for voice, 500 kilohertz for MCW Morse. And it came in a bright yellow suitcase, which was allegedly buoyant. I never got to test that though. But part of the job was to test this thing weekly to make sure it transmits and receives. So it had hand cranked handles or pedals. So you used to get somebody to do that with it and get the power going. And basically send a couple of dits on the Morse key to make sure it was actually transmitting something, or perhaps say while low into the microphone, make sure it's going out. And yeah, that was part of the job. Some ships also carried EPIRBs, EPIRBs, Emergency Position Indicating Radio Beacon. And that generally worked on 121.5, so that's the aircraft distress frequency. We had them back then, they're still around, I think they're still being used. Batteries. For some reason, it was the radio officer's job to look after the ship's batteries. I used to have a pair of trousers that were full of holes from doing this. The acid got everywhere and it just burnt through anything it touched. But this was also checked regularly. You had to check the levels and you had to check the specific gravity These were not maintenance-free car batteries. These were proper lead-acid batteries with open tops, and you had a hygrometer, is it? Hydrometer? Yeah. Check the specific gravity and is the level okay? Yeah. So that was particularly important in tropical regions because these used to evaporate very quickly. And the radar. So the radar was typically both 3 and 10 gigs. There were different reasons why the two different frequencies were used. I think 10 gigs gave greater precision and 3 gigs gave greater range or something like that. But it was generally S-band and X-band radar. Remember, we're talking about the 80s, so the receivers were quite primitive. They used crystal diodes. They were very, very fragile. Lightning strike could kill them, so that was a regular thing. Go and change the crystals. The scanners, they would also...
1N21F.
Possibly, yeah. They look like little bullets, yeah? Like, or a bullet with the lead projectile taken out, like the cartridge case, yeah? So the scanner was also prone to failure, particularly in storms. Had a drive belt, a bit like a fan belt. Of course, if it failed, it would fail in the worst possible weather, and the job was to go up the Monkey Island and change the fan belt in really appalling weather very often. So that was part of the job. Not this 8 hours a day isn't sounding quite so appealing now, is it? This is the sort of equipment we were using. What I'm going to talk about is what I was trained on at college, when I actually got to see the radios were all Japanese, JRC. Still valves. The main transmitter had 4 4CX250Bs in it. But what I was trained on in college was a Marconi Conqueror, which was very often the ship's main transmitter. It's at least a kilowatt output. So you had a synthesizer exciter, which would generate CW, MCW, AM, actually A3H, A3A or A3J, which I think A3J is now called J3E. A3H is now called H3E, something like that. Yeah. Anyway, basically AM, proper AM, or upper sideband with reinserted carrier. So it could generate all of those. Had a digital display, but it was Nixie tubes.
Oh, yes.
Yeah. 100 hertz steps. Everything else was pretty much valved. As you can see, you had these 3. Anybody recognise what those bottles are?
TT something or others? TT.
Okay, whatever. But I don't know either. But there were 3 of them in this particular transmitter. This big knob with the handle on was the band selector, and then you had big capacitors for anode and aerial, a bit like a modern ATU, right? And then anode aerial current. You didn't tune for power; you tuned for maximum amps into the aerial, because the aerial was like it was just a fixed length of wire. So the whole idea was just tune everything up to get the most current into the aerial. That's all you could do really. But typically you'd be doing about a kilowatt with these things. So that was the main transmitter. Your standby transmitter, it's got a Morse key built in the front. Yeah, and it's all out of focus, but if you flick that switch it would send the SOS and the long dashes automatically. So if the radio officer had bought the farm, the deck officer could come and throw the switch. He would at least know how to do that. But this ran off 24 volts, had a 6146 in the output. I remember that quite clearly, with some sort of transistor inverter for the HT, which all ran off 24 volts. And again, there's your aerial tuning, some sort of inductor and a capacitor. And where the frequency? Yeah, somewhere on there. Oh, there it is. There's your 410, 425, 454, 480. 500, well, 500 is marked in red because that's the emergency frequency, and 512. So there's your frequency selector. Something we didn't used to think about was using a kilowatt on top of a boat full of oil.
Oh.
Didn't think of it in those days.
Yeah, but everything was effectively up, wasn't it? You know, it's just a ship.
Yeah, what they used to do. Yeah, the empty tanks were inerted And the way they did it, they pumped exhaust fumes from the ship's engine into the top of the tanks, and basically it was inert. Yeah,
Yeah.
you certainly couldn't breathe it. Main receiver again, Dixie tubes. You occasionally see these on eBay, Marconi Apollos. So this was sort of down the long wave, right up to 30 megs, and had a variety of filters. You could have narrow CW right up to sort of AM bandwidths. Yeah, that's not much to say about it really. It's just a general coverage receiver. I love the Nixie tubes because the numbers used to go in and out because all the digits were arranged behind each other. It's a weird effect. Is your lifeboat radio, your hand cranks. These will sort of plug in and you turn it and it generates electricity. It was only a couple of watts, but if that's all you've got. And that will come with, there's a whip aerial that's stowed in there. There's a wire aerial if you can throw out a wire. I'm not sure what you're supposed to do with a wire aerial and a lifeboat, but there's a wire aerial in there as well. There was a length of...
Kites and
all right.
balloons were used.
Yeah, okay, I don't think there's a kite in there, but that might be a solution. There was a length of thick braid with a weight on, you threw that over the side and that was your earth. And it, when you, allegedly, never tested it, but allegedly when you sealed it all up and locked it, it was supposed to be buoyant and bright yellow, so if it fell overboard you'd be able to find it.
How heavy was it?
I should, yeah, it was as much as you could do to lift it.
Really?
Yeah.
Oh. That's important.
Right, so non-radio duties. Tuning the TVs in the officers and crews lounge to TV channels when available. Right, so if you were anywhere coastal, yeah, you might be able to get a few local. This was the 80s, remember, no satellite TV. But it was multi-standard TV, so you'd have VHF and UHF, and you might be able to get something. Apart from around France, I'm sure Dave... I think it was something to do with the positive going modulation as well.
They used
it was CCAM. Yeah, VHF was 819, UHF was 625. So the 625 wasn't the problem, but the video modulation was positive going. Everybody else used negative going modulation, so it couldn't even lock onto the sync pulses.
So it wasn't peace at last.
Yeah, no, indeed. Yeah, yeah, but if that's all you've got.
405 lines was positive going as well.
Oh, was it? All right, okay. So, but I think the UK had got rid of 405 lines by the early 80s. I think the French still had 819 on VHF.
405 disappeared at the end of '84.
Right.
For the last one was Crystal Palace.
Right.
Because I was about to take a picture of it just on the night it was going to go off.
Yeah.
And my brother phoned up. I phoned up, chatted to her briefly, and it was gone. I thought, that's it. Well, I thought they were going to turn it off at midnight. What actually happened is there were two turning off ceremonies. The management wanted to have their turning off ceremony sort of like 7 or 8 o'clock in the evening. So they turned it off. Then they turned it back on again.
Yeah.
And the ordinary maintenance crew turned it up at midnight. So if I waited, I could have got it. But
What
I
actually
didn't know that.
happened was that the memory transmitter failed, and they couldn't get any of the parts anymore. So they couldn't repair it, and so they were waiting for a flood of people complaining. Nobody complained.
Nobody noticed.
So they said, "Oh,
might as well turn all the others off then." Okay. Oh, so yeah, scheduling videos and 16mm movies. And you had 16mm movies. You used to get rid of the old ones and bring a load more in, and there'd be pre-recorded films and some TV programs. I remember Minder. We used to get videos with Minder on. The big thing was posting the football results every Saturday in the lounge, because there were two lounges, a crew lounge and the officers' lounge. We still had social segregation in those days.
So you're supposed to be interested in football, are you?
Allegedly, I wasn't particularly bothered. But this was part of the job. The football results were broadcast every Saturday evening by GKA, Portishead radio, in CW, right, on all of the H4, 6, 8, anything that had valid propagation to anywhere else in the world, they transmit it, multicast it basically. And yeah, it was more than your life's worth to get it wrong.
You had a pool entry as well, did you?
The what?
Entry for the pools as well.
Yes, yeah, well, people were doing the pools, and very often there was betting going on amongst the crew about who would win. So you can imagine if you got that wrong.
Would that be all divisions?
Yeah, I can't remember now, it was that long ago, but certainly, yeah, there was no Premier in those days. It was Division 1, 2, 3 and 4, and I think there was a Scottish division as well, wasn't there? I suppose we were lucky. There were a few Maltese on the ship, but we didn't do the Maltese football results. Mending anything electronic belonging to crew members, right? But basically, it was radios, because I don't think even Sony Walkmans had appeared at that point. So,
What were we talking about, early 80s?
very early 80s, yeah. Right. Okay. It was certainly sort of the boom boxes, you know, the combined radios and tape recorders, but there's not a lot you could do with a tape recorder without spares, so it was generally the radios.
And being a radio man, you had a stock of spares.
Oh, yes.
Not really, no. We had spares for the radios on board, yeah, but not for some Japanese boombox.
With a bloody great valve stuck on.
Yeah, replace the local oscillator with a 4CX250. Okay, and that was the ship I was on, the Vic Beale GCHZ. In case anybody wondering what on earth was that name, Vic Beale is an area in southern France famous for wine production. It was manned by BP officers, but it was actually operating on behalf of ELF, which was a French oil company. Right, so yeah, spent.
MV means maritime vessel?
No, a motor vessel, as opposed to SS, which is steamship, or NB, which is.
NB.
NB, you must know what NB is.
No.
Oh, come on, narrowboat. So, yeah, so. Anyway, that is, I always found that Seaman Discharge book. I always thought that was a slightly funny name. So there you go. That's what you got at the end of your however many months. You were signed in and out again by the captain. So
what did you carry in that vessel?
that's a 100,000 ton oil tanker.
Right.
So during my time on that ship, we were based out of Donge, which is near Saint-Nazaire, Nantes, west of the River Loire, west of France. We went down to Nigeria, Gabon, into the Mediterranean, through the Suez Canal out to Ras Tanura, Saudi Arabia. We did a bit of British coastal waters. We did some what were called lightering operations. Lightering was taking oil off a larger ship to make it more buoyant so it could get deeper into coastal waters. So we did some lightering operations of larger ELF operated vessels. We went up to Scarpa Flow. I can't remember why, but I remember going up to Scarpa Flow. We did Humber, Immingham, which is near Hull. Yeah, so yeah, that's what I spent 5 months doing.
So your lightering operations, was that by putting a buoy across between two ships that were sailing at
Yeah,
the
what
same
you
time and then haul a pipe across?
can you? I don't know if you can see that. There's big black things there, and there. This ship was actually specifically designed for lightering as one of its design requirements. These were actually fenders that were lowered out on davits, and the two boats would come alongside, and you would pump oil from the larger ship into this smaller ship. Yeah. I'm sure there was a valid reason for doing it, but
Because if you think about going through a lock that's not deep enough.
yeah,
you know,
quite possibly.
or
Yeah.
something like that.
Pretty big log for a ship like that.
Yeah. So yeah, how are we doing for time?
It's just gone 9.
9. I've got the other talk on little boats. Do we want to take a break for another cuppa first, or should I just go straight on? What do you want to do? The other talk will take about half an hour.
Half an hour, so half quick to an hour.
Yeah. So we just carry on then? Yeah, okay. How about that? Isn't she beautiful?
Not as good as she should be.
Oh, why?
Because of all the paint problems.
Okay. You can't see that until you look close up.
So you can't see it.
Okay. Operating from a canal boat. As you may have gathered, David and I own shares in this boat, which is currently at Anderton in Cheshire, near Northwich, that sort of area.
It's about 100 yards from the Anderton boat lift.
Yeah.
Okay, yes.
Yeah. The Anderton boat lift is a device that lifts from the.
It does what it says on the tin.
It does. It lifts between the canal and the river Weaver. There we go.
Has that been in it?
Yes, it has, but not.
Not with me.
Not with him, but
I'm scared of it. If you saw this thing, I'm not getting in it.
At the moment, the boat is broken, and there were a whole load of.
Obviously, VHF and UHF is easy. It's quarter wave mag mount for 4 and 7/8 for 2 meters. Don't know who that is over there.
That's me.
That's you. Right. So that's how you do VHF and UHF. That's easy. Well, for FM anyway. You want to go on HF, this is where it gets a bit more complicated. You know these triple mag mounts, have you ever seen them? Yeah, I've got one here. Here's one I made earlier. Now these, when you buy them, see that? Three big magnets on a triangle. When you buy them, they come with something like that. So you stick that through there, or mount it on there somehow, and that's where you stick your big CB aerial usually. These were designed for CB aerials, right? Which is
CB diameter coax.
yeah. So that's how you're supposed to use them. You'll notice I've drilled lots of extra holes in that one. Right. The reason is, put that there. It's reasonably clean. Oh, right. So this device is a Codan tuner. Covers 2 to 30 megs. And that, you'll notice I've drilled 4 holes in a square there. Those 4 holes there. The earth wires obviously get screwed on together. So that goes on like that. The idea of the earth wire... yeah. I don't think they're magnetic now, are they, credit cards?
I think we've still got magnetic.
I don't think you can see there's some brass things holding the ladder and the bill hook thingy on there. But what I do is I fix that earth wire to this brass there with a Jubilee clip, because that is actually well bonded to the metalwork of the boat. So that is a perfect earth. Yes, it works. Works very well, in fact. I've worked Martin on 80 metres from Northampton, or from Gayton area.
Yeah.
Yeah. So that was with, yeah, that was with this, with a 3 metre whip. So that's the first way of modifying one of these things for HF. That's the control, that's the RF, basically. And you just poke the wires through a convenient window. There we go. So you can see
that's pre-paint job. That's the old paint job, because we don't have those windows anymore.
No, there's a black swan there. Look.
Oh yes, we do. Sorry.
Yeah, we do.
Yes, we do have windows.
The old paint job just had a big number, didn't it?
Just ignore me.
I was going to say it's not that old. So there you go. You get a 3 metre whip, which goes on this big spring. You cannot use this while you're moving, by the way. Some of the bridges, you've got about 2 feet of clearance. The 4 metre whip bends over, but that's about all you can do with it. So that's how you do HF. Yeah, so it's fine when you're parked up, but obviously, and you're generally too busy. Sorry, moored up.
You may know a lot about radio.
I still refer to the blunt end and the sharp end. So there's your 3 metre whip. It certainly works on 80 metres. You can get out on 80 metres. Unfortunately, this last week, by the time I'd moored up each evening, 80 metres was just for the European stuff, so I gave up with it. I tried listening out on 3615, which is the AM frequency, and there was QSO going on, but there was a much louder, lower sideband station, 0 beat with them, and I think he was speaking Hungarian or some such language, and he was louder than the AM stations, and basically they were demodulating his LSB because he was 0 beat with them. So it was probably not worth doing this time round. What I did do was that. Right, last Tuesday was the UK AC contest on 2 metres. Same triple mag mount. You've ever seen these fans that, yeah, household fans, right? Okay, and you've got this thing that sort of locks in and the fan sits on top of there. Yeah, the fans only last a couple of years and they all gum up and seize up. And I was about to throw that out and I thought, hang on a minute, I can think of a use for that. So I drilled 4 more holes. so there's the 4 outer holes are for that device and the 4 inner holes for that with M6 screws and nuts to hold it all together. And that is...
Did that already have those holes?
This already had the holes, yeah, because that screws into these sort of cross things that hold the fan up, basically. But yeah, so put that there.
I've got one of those fans. It's working okay at the moment. At some point.
Well, you can borrow this if you want to next week.
No.
You don't do radio.
Not when I've got Joan and Dale.
Oh, of course you don't. No, okay, but
If
sometime in the
I was on my
future.
own, I probably would.
Oh, you're very welcome to anyway. So yeah, that's how you do VHF. That's stable enough to stick a 4 metre pole in. Sorry, 4 foot pole. And that's a 4 element Yagi for 2 metres. That was just outside Middlewich, and that's facing roughly south.
That's in Cheshire, is it?
Yeah, Middlewich, Cheshire. Yeah. It's between Northwich and Nantwich. Yeah. They were. No, that's the beauty of it, because you park somewhere like that and there's just no noise. What?
And also the Armstrong reference tuning or rotating.
I just left it pointing south. So that's yeah.
Oh, what about the AGM?
So yeah, that's. It's probably not that much on a 4 metre. A 4 element Yagi anyway. It's gonna work. In fact, I did work a GI off the back of the beam, as you'll see in a minute. So there's 2 metre Yagi for sideband. Obviously, that could hold up any band. Just depends which week you're out and which UK ACs are on that week. There's the 2 metre, 4 metre Motorola radios. The look 3615 VMARS. It's the AM calling channel for HF. And that was the 2 metre radio that I used in UK AC. So it was a FT817. And it's actually 160 watt amp, but this really only drives it to about 40 or 50 watts, so it's a nice clean 40 or 50 watts. You're not going into compression with it. What did I work? Sorry?
That's probably a sensible power to use in
Yes, yeah, I mean, it worked quite well. Alright, so I did a bit of FM. I worked 3 stations on FM during the FM hour.
G4KFK.
All in, where are we? 1083 square. Alright, so they were all locals, obviously, at least within the same square. But we also worked GW.
You work Yuri.
I worked Yuri at GD. That was off the back of the beam because I just left it facing south. So GD was off the back of the beam. And there's a GI4 SNA off the back of the beam.
It's on a typo, you've got M0BB just on.
That's
Yeah, it's got a short.
that was what he was using. Yeah. So yeah, worked 20 stations in all, 17 on sideband, 3 on FM, and that's where we were So yeah, obviously most of the stations were in the direction we were beaming, but we worked Isle of Man and Northern Ireland, and that remember that was from this is probably head height.
Yeah.
That's maybe 8 or 10 feet off the ground.
But bigger canal, you're not that high. Was it?
It's, yeah, the whole idea of doing a VHF contest is you go and park yourself on a hill. Well, you can't do that in a canal boat. So I was pretty pleased with that.
If you were on the K&A, because you could go on the top of Crofton Hill.
Okay, yeah,
That's pretty high.
okay. That'd mean going up a load of locks, wouldn't it?
5.
Right.
Well, it would just to get to Crofton, but you've got to get to Crofton
Yeah.
from wherever your boat is, don't you?
Okay.
So you were missing 93 and 94, probably the point of my reasons that you were beaming south.
Yeah, they'd be off the side of the beam, wouldn't they? Whereas these guys are off the back, so yeah, they probably stood more of a chance than anybody.
You've got to figure out how to put a rotation on it.
64.
Well, my idea was to drill a hole in the boat with put a big grommet.
Do it like a periscope.
Yeah. So if you find a 2-inch hole in the top of the boat, you'll know why. Yeah, so canal boat radio doesn't work everywhere, of course. David would probably remember where that was.
Well,
I don't know.
what sort of
You were
frequency-
driving when I took that picture.
What
that-
sort of frequency
hair
would that
castle?
be a waveguide on?
It's Hare Castle. Yeah, so that's on the Trent and Mersey.
Yeah.
Okay. Any questions about that? Because I'm QRU now.
Well, yes, before we all get a little bit talking about things and everything, just like to thank Mike for
Of a little one.
2 talks, both very fascinating,
Yeah.
and
Very good.
very pleased that you've done that. Thank you very much.
Thanks for your attention.